Okay, this is just getting started with the MultiSim. And so what we're going to do is we're going to create a little circuit. It's just 12 volts through a resistor here, and then we go through a parallel circuit here. And we reduce the circuit, take these two in parallel, we get that value 1428. And then we put them all together and we can figure out the total current, which is 1.96 milliamps. And then we go back to our circuit. So we have this total current 1.96, and it divides up two ways, I1, I2. And we use the current divider, and we find that I1 through the smaller resistor gets a bigger value, 1.4 milliamps, and the other one gets a 0.56 milliamps. So we're going to set this up, and then we're going to show how you can do some different things with the MultiSim. For instance, you can find the voltage. So we're going to find voltage, current, and then we're going to look at power. And we'll see how that works in just a minute. So anyway, what we have here is I have my student edition of the MultiSim. And let's just fire that up. And here's the blank screen. Basically what you're going to work with is you're going to use, this is place. And here's where you can put components on. And what we're going to do is we're going to start putting little components on here. And you kind of have to find your way around, but basically what I like doing is if it says what group you're in, as we first start out, we get sources. And what we have there is we have your power supply. This is DC power, AC power, and there's your grounds. So what we're going to do is we're going to say, okay, we want one of those. And it's over on the left-hand side, so we'll put it somewhere over on the left. And it's 12 volts. Now we want to put our ground in there. There's a symbol for the ground. We'll say OK. Now we're going to put that at the bottom of our circuit, and we'll just put it there. Now what we want to do is we want to go, there's all these families, and one of the things that we're only going to talk about basics, what you need for ET130. But if you are really wanting to use this is a powerful tool. So it's got analog circuits, it's got all these digital circuits, it's got mixed signals, all sorts of things, RF if you're into antennas, but you have to look at it. What we want to do is stick with basics, so we're going to pick basic. And in here you have these rated virtual, and what I do is I just say rated virtual, and we want resistors. So we say, okay, and we'll put the 1 series resistor in there, and we'll say okay again because we want another resistor. And when you put them, one of the things you have to be careful of is put them in order, because these things, as you set them down, now those are 3 resistors, so we're finished with the circuit. They put them in order, so it puts R1, R2, and R3. And after you lay it down, if you decide that you want this one to be R1, it's a little problematic in changing the R numbers because they do it in consecutive order, so try to plan ahead. Anyway, we want to make these parallel, so what we want to do for these is we want to click on this and we want to rotate these just 90 degrees so they look more like our circuits. Now in our circuits we have this as a 4.7, so what we do is we just click on the 1K value, double click on it, and this gives you all the parameters. And the two that you really need is this is the value. We want this to be 4.7, and that's okay. And the other value that you want to be interested in, now this is going to be a 2K resistor. The other one is the power rating. They all come in by default at a 1/4 watt, but if you have higher power circuits, you need to account for that. If you need a 1/2 watt or a 1 watt resistor, you have to account for it, otherwise the simulations will not run. Well, they'll run, but not for very long, like half second maybe. And this is 5K. So we've got all our components in the circuit. Now we have to connect them. So we go back into the place, and in here is the wire. And for the wire, all you have to do is get on your starting point, click on it, and go to your stop point and click on it. And there's like a little, it's hard to see, but there's a little red dot that shows up when you click on the point. Now when you actually make the junction with two wires, it has that little dot, and you can see that dot. And so if we complete our circuit, we want to go down here, and we'll complete that down to there. This guy has to go down to there, and this guy goes down to there. So now we have the full circuit. Now we can look at some values, and if you want, what you can do is, if you want to move things around, you just grab them, move them around, and the circuit stays intact, which is a pretty good thing. And so you can just move your circuit as needed. Now what we're going to do here is part of the things, and when you simulate things, these instruments, they have all these functions. Now for what we're doing, we're just going to basically do a multimeter because we want to measure voltage and current, a watt meter if we want to measure power, and for when we get into the AC, we're going to use a lot of the oscilloscope. But you can use, they've got all these other things like Bode plots if you're doing, I don't know, control circuitry, frequency counters, logic analyzers for digital stuff. There's all sorts of stuff that you can get into, but we're just going to stay here on the top with the multimeter, watt meter, and oscilloscope. And to grab those things, you can either grab them from there, but over here they have the same thing: multimeter, function generator, watt meter, oscilloscope. So we want the multimeter, and if you just click it once, you can see that it appears over here. Then you can click it, and it will highlight it, and then you can drag it over to where you want it. Now for this, what we're going to do first is we're going to measure current. So we're going to put it right in the circuit. Now with all the current meters, you can't have it like this. So what you have to do is you have to click on that little thing in the middle and delete it. Because the current meter, it needs to go in one output and out the other. So it has to break the circuit. So it goes in here and out here. And if you remember, the way current flows is the current goes from the negative terminal around the circuit into the positive terminal of the battery. So we want the negative going into the negative and the positive going into the positive. That way we'll get our true reading of current. So when we look at this, we say, okay, this will tell us whether we're going to measure amps, volts, or ohms. And what we want to do right now is measure amps. So we're going to click on the A, and we can actually put this in the middle of our screen. And so now we're ready to run because we've got our circuit. We've got our circuit, and here is your run. It's a little green arrow for run, and then it becomes a red square for stop. So we're going to run it and see what happens. See if we get our 1.96 milliamps. And it takes a second to go, and well, 1.958. So that's within round off. So we got our right answer. So this is the way you can verify circuits. So now what we want to do is we want to go in here. We're going to stop the circuit for the time being. Now we want to measure voltage, and we want to measure voltage across these resistors. We might as well do it across all three. So we can just click on a multimeter again, and we move it into position. Now for here, well, we can kind of move this one, put them right up here, and we're going to measure, well, to make it look like something, we'll try to move all this stuff a little bit down, give us another little bit of headroom here. And now we can move the meter into a little better location. And now what we want to do is we want to take its lead. Now for voltage, you don't have to break the circuit. All you have to do is put him into where you want to measure across. And we'll get another one. And what we'll do for this guy is we'll move this guy out. And then let's give this guy room to kind of sit and maybe rotate him. And we'll connect them up across here. Yep. Sometimes connecting the dots, they don't want to cooperate very well. And when we do this, we'll just take a look at this. For this meter, we're going to measure voltage. And voltage is the default. So both of these meters that we added should be voltage. And we'll add one more for our last resistor. I mean, yeah, R3. And we'll rotate him too. And connect them up. Okay, so now if we run the simulation, and what we'll do here, okay, this will be the meter for this guy. We'll put this guy over here, and we'll maybe put this guy down here. And we will run the simulation. This is our current. This guy, again, is the voltage across R1. So we've got 9.203 across this resistor. Number 3, we've got 2.8 volts, and we've got 2.8 volts across this one. And because they're in parallel, they have to have the same voltage drop. And you'll note if we add this one up, the 9.2 and the 2.79, that adds up to 12 volts, which it should. And what we can do right now is let's take a look back at what we saw in our formulas. We got 9.2 across R1. We got the 2.8 across R2 and R3. So that is correct. And if we go back to looking at this, if we wanted to change this to see what's the current running in this leg and the current running in this leg rather than voltage, we can stop it. And for the time being, I'm going to close these guys out. Can get rid of these wires. And now what you kind of do is kind of move this guy down. And so what we're trying to do is we're trying to measure the current running through here. So again, we just plop them down right on there, but because we're measuring current, we have to break that circuit. So we just highlight in the middle, delete it. So now again, we're going from the negative lead, we're going into the negative lead here. And if we do the same for this guy, we'll delete, deleted a little too much there. We want to delete just that guy, and we'll move that guy down, move this guy into place, and delete that. And now what we're going to do is we're going to set up both of these guys to measure current. So we'll click him, we're going to measure him at current, and do the same for this guy. We're going to measure current now. And so now we know that, and this guy, we don't really need him because all we're doing is looking at current. So now we've got our 1.96, that's the total current here, and that should divide equally into this branch and this branch. And what we saw before was 1.4 going in here and the 0.56 going in here. So let's run the simulation, see what happens. And how about that? We got our 1.4, and just because the way this is 0.56 milliamps. It just, whatever the type of notation it uses, it just comes out into this factor. And I'm sure you can adjust that, but I haven't figured that one out. But anyway, that is the very beginnings of how you do the MultiSim. And again, it's a very powerful tool. It can help you a lot. If you're unsure about any of these things, and we'll have more examples, but if you're unsure about whether you have the circuit working correctly or not, you can just use these tools. They're kind of, you know, like anything else, it takes a little getting used to, but once you get used to it, you'll find it's a very valuable tool. And that is the Getting Started with MultiSim video. Okay, and this is for our getting started. I guess we were looking at the thing and said that we were also going to show you how to do the power for the components. So what we need to do is we can get rid of these meters. And what we'll do is we'll select our watt meter, which is this watt meter over here. And we'll bring it into position. Okay. Now here we're going to rotate this guy again. And what we want to do is we want to grab the current. So we'll go from there to there. And move him just a little bit. Then go from there to there. And I guess, well, we're going to have to do try. Okay, and then we need to grab the voltage. One voltage is going to be ground, and the other voltage we want to get across the resistor. So we'll try to do the same thing for a second watt meter, and we rotate it. Okay, we'll grab the current, got the Gazinta, and part that goes back home, and the voltage, tie that into the ground bus. And we'll tie this into the other side of the resistor. So hopefully the circuit, the way it works is circuit, the current, well, I'm not sure what that guy is. And we need to pull our ground out of the, reposition him since we moved everything around. So anyway, now what happens with our circuit is we've got the 12 volts, the current comes out, and this is ground all the way through. But it comes out, it goes into that resistor. Now we have to break it and go into our current watt meter and then out and back. Same thing happens over here. We break the circuit for the current, and the voltage just go between ground and over the other side of the resistor. And so anyway, let's put our watt meter, that one up here, and this watt meter down here. Okay, and now let's see what happens when we run the circuit. Okay, this one says 3.91 milliamps, and let's see what we had in our circuit. We said that this one, R2, is going to be 3.92, and this one's 1.57. So 3.912 and 1565, that's within tolerances. So that's the way the watt meter also hooks up. So that gives you a visual of how you can hook up your current, your voltage, and your watt meter. And again, the only other thing that you really need to know is pretty much the oscilloscope, and we'll take a look at that when we do one getting started for AC circuits, because the oscilloscope is pretty cool and pretty useful, and you'll use that a lot. And that is the final for the first installment of getting started.